All right, so this week is going to be about taking a look at changes in physical properties or chemical properties. So we're going to start looking at the idea of chemical properties as well, but physical and chemical changes. So that's what this week is. A relatively light week here. So let me move me out of the way. There we go. So this is on page 14 of the e-text. It's just talking a little bit about the differences between physical and chemical changes. So physical changes are pretty easy to identify, in my opinion. They're usually like changes of state. So if you have the same material that just melted or condensed or evaporated or whatever, changed between a liquid, solid, and gas, that's a change of state. That's a physical property. So if you have water that froze, well, it was liquid water and now it's frozen water, right? It's still water. So that's a physical change. Changes in color, a lot of times can be physical changes. Changes in shape, right? So you take something, take a note card, and you tear it up, right? So that is, I was looking for a note card, and I don't have one. That's a physical change, right? It's still a note card, still a piece of paper, right? Changes of volume, right? If you add more, take away more, or if you heat it or cool it, right? Sometimes that can cause changes in volume, like in a gas. If you've ever put a balloon in the freezer, right, you'll know that it actually shrinks because of how cool it gets. So that's a change in volume. These things are usually pretty easy to reverse, right? So if you freeze something, you can thaw it out, right? So that's a physical change. Chemical changes, on the other hand, are usually not as easy to reverse. A lot of times they can be so energetic that light is produced, and we'll talk about that in just a second. There can be changes in temperatures, and now that's not saying that external changes in temperatures, that just because you mix two chemicals together and all of a sudden it gets hot or it gets cold, that's a change in temperature due to some sort of reaction going on. Effervescence, I love that word, effervescence, just means bubbles. Bubbles are produced. Now, that's not always the case, not always the case. We'll talk about that in just a second. The production of a smell or the production of electricity, right? And I say production of electricity, not that it conducts electricity, because water can conduct electricity, but the battery acid in your AA batteries, right? That is the production of electricity. Now, these two things can happen simultaneously. So for any given process, you could end up with physical changes as well as chemical changes. And that's actually where this activity comes from. So on pages 19 and 20 in the e-text, you're going to be burning a candle, and I'm going to do this for you. I'm going to make a video and stick it in here, so we can take a look at the properties or the changes that happen with burning a candle. So let's take a look. All right, so this is the setup that we have for the burning candle, part 1 and 2. So I'm going to show you my book here so you can kind of see what it looks like on the e-text, right? So burning candle part 1 and 2, which starts on page 19 and goes through 20 and 21, I believe. Yeah, 21. So basically, we're going to be taking a look at what goes on with a candle. And there's a few things. Now, I mean, if you read through the instructions on this, it says to get 3 birthday candles. I don't have birthday candles around the house. Actually, I have old birthday candles. So this was actually a 0 that I've disassembled. So got a little bit of a wick right here. Got the wax. Got some other types of candles just for purposes, or if we need to show, we can. So the first thing is that we just basically need to take a look at a candle and see what we have. So we have obviously a piece of wax, white. So this is all of our observations that we can have. Qualitative observations is this particular one is white. It's very smooth. It's waxy, right? It's got a wick, and my wick is burned a little bit, but some wicks can be coated in wax when they haven't been burned yet. So that was a new candle there. So that's the main components, right? So we have a wick that goes all the way through the center. We got wax, and we need a flame, right? So in part B, what we're going to try to do is we're going to try to disassemble this and see what goes on with a candle in its parts. So we have some wax right here. We got a little bit of a wick right here, and I've got a flamethrower. I've got a lighter here, and we're going to try to see what is going to happen when we try to light these on fire. So we're going to start with the wax. So I'm going to try to light the wax on fire. Okay, hopefully you can see that this is not really working for me. the wax is not lighting on fire. It is melting though, right? So I'm trying to light this on fire and it's just not taking the flame, but it is changing state, right? So it's melting. You can see some of it right there. So I don't know what's going on with the wax. It's melting, so I don't know what does that do with the candle. So let's take a look at this wick and let's try to light the wick on fire. Let's see what happens. Okay, so we got the wick to light on fire. Let's watch it for a little bit. There we go. Okay, but looks like that entire wick is now on fire. And it is fizzling out. So the wick is definitely something that can start a fire, right? Can catch on fire, but it is not very long, right? We would like candles to burn for quite a while. Get the smoke out of here. I don't want to set my smoke alarm on fire or on. That would be bad. So we have the wax, which doesn't burn but melts, and we have a wick, which does burn but also burns pretty quickly. So that's part B, right? We've made some observations about that. So in part C, we're going to take a candle here. I'm just going to light it on fire and make some observations here. All right, and now we have a flame, right? We have a flame. I can pick this up maybe for a little bit, bring it close. All right, so we have a flame, and it's not going out, right? We can see that the wax is melting, but the wick is not burning up like it did here. It seems to be just kind of on fire, and it just keeps going. So that's kind of interesting. Something about the wick and the wax being together that allows the flame to kind of sustain itself. And I don't know if you've ever had a candle going for a long period of time or just owned a candle that you've lit over and over and over. I mean, eventually the wax disappears. And if I keep this candle going for a while, we'll see the same thing. That, yeah, the wax melts, but it also starts to go away. It literally disappears. So there's something that must be happening with the wax when it's heated up by the flame that is keeping the flame going. That seems like it's an observation. It's not really an observation, but it's a hypothesis that we have, right? Our observations are that the wax by itself doesn't catch on fire. It just melts. The wick by itself will catch on fire and it will burn itself out pretty quickly. But when you have the wax and the wick together, they seem to work in some sort of way to sustain themselves. And while the candle is burning, the wax disappears. So it is reasonable to hypothesize, right, that the wax is offering some sort of fuel to the flame to keep it from completely consuming the wick, at least very quickly. And so as time goes on, the wax eventually disappears. So our last part is to take this candle and we're going to put something over it to kind of cut it off from the world, and we'll see what happens. Yeah, so you can kind of see it from the video. So yeah, the candle went out. I always want to try to do this. I was going to try to light it. I was going to try to light it with the smoke. So what happened there? When we covered it, when we removed it from the environment, the flame went out. So it's almost like it needs a constant. What would be a good way of describing this observation? We don't want to put too much into an observation right now. You probably understand that fire needs air, right? But we don't necessarily have that observation that fire needs air, other than the fact that when we remove it from an air source, right? When we remove it from an air source, it goes away, right? So something along the lines of having access to fresh air also seems like it's sustaining our flame. So a candle kind of needs three things, right? It needs the wax, which offers up some sort of fuel, maybe. It needs the wick, which is the actual thing that burns, but if it were to be by itself, it would burn too quickly. And then, of course, it needs the air, fresh air, whatever that does, in order to sustain that flame as well. If you remove the air, the flame goes away. So those are our observations. So on page 21, when you're looking at burning the candle part 2 for homework, what you're looking for are the physical and chemical changes. Remember that a physical change is like a change in state, kind of like maybe the wax melting. A chemical change is when something is turned into something else, right? So we did notice that the wax was disappearing, so that probably would be turning it into a gas of some sort, but I've never heard of wax gas, so it's turning it into some gas, and that would be a chemical change. So go through and see if you can answer those questions, and then you're going to submit it for homework. So let me know if you have any questions. Okay, so what you're going to do for homework then is you're going to finish up page 21. You're going to answer the questions on page 21 based off of what we did and in the video on burning a candle and the physical and chemical changes that happen because of that. So let's take a look at the next part. So again, this would have been an activity that we did in class, and so I'm going to show you a little video here. Properties of white powders. Basically, you can identify the white powder based off of its physical and chemical properties that it shows. So here's a video. And mute it. So basically, they've taken 4 white powders. They have salt, and so you can see what salt looks like. I'm going to talk through this. May jump around a little bit. They have sugar, cornstarch, and soda, and baking soda. So here's what sugar looks like if you've never seen sugar before. All right. Ugh, the menu's in the way. There's cornstarch and then baking soda. Now, what they're going to do is they're going to take a look at these particular white powders, and they're going to see how they react with 3 different liquids. So you can see they have all 4 of these, but they're going to mix it with 3 different liquids. And one of those liquids is water. And I don't know if you've ever mixed water with any of these. You know that there's nothing really groundbreaking that happens, right? The salt, the sugar, they dissolve. Cornstarch, cornstarch in water kind of makes that oobleck that we saw last time. That's still not a chemical change. It's just a physical change. Okay, same thing with baking soda. Nothing really happens. So the next thing that they're going to mix with it, I believe, is vinegar. Yep, vinegar. Okay, so again, vinegar with the salt, right? Nothing really happens. Vinegar with the sugar. Nothing really happens. Cornstarch. Nothing really happens. And then baking soda, you can see, oh, we're starting to get bubbles, right? So that was an indication, right, from our list that a chemical reaction has happened. So a chemical change. So far, they've all been physical changes except for baking soda and vinegar. Now they're going to take iodine, okay? And this is iodine. Sometimes iodine's used as an antiseptic. So iodine on the salt. And iodine is naturally this brown color, so nothing really happens here, neither on the sugar. Iodine and cornstarch, though, take a look. So there is definitely a color change there. It turns to this bluey, blacky ink. So that happened. And then it didn't really do anything with baking soda. It might have been a little bit darker, but it's still brown. So there's another chemical change right there. So cornstarch and iodine. So the only thing that was produced a chemical change was the baking soda and vinegar and the cornstarch and iodine. All the other ones were physical changes. Now, a quick note about dissolving, because that's what happened when you mixed water and even vinegar with some of those things, is that it dissolved. So I'm going to let this kind of play, and I'll jump around with it a little bit. I don't know if you've ever made rock candy. In fact, over the summer, I made rock candy with my son, and he had a blast with it. Didn't really eat it, but it was pretty sweet, and they came out. So when you dissolve something, is that a physical or chemical change, right? Taking sugar and dissolving it in water, is that a physical or chemical change? So I want to get to this point, but I can't. So the idea of dissolving is, let's say you dissolve sugar in water, like what they're about to do, right? Is that a physical or chemical change? Did the sugar go away? Right? Or did the sugar turn into something else? Any of you have ever drunk sweet tea, right? You know the sugar hasn't gone away because it's sweet, right? And in fact, the reason why you put the sugar in while the sweet tea is brewing or right after it's brewed is so that you can dissolve more sugar into it. And that's what raw candy is basically all about. Is they heat up some water, dissolve the sugar into it, and they heat it up so much that you can dissolve even more sugar into it, so it becomes a saturated solution. And then when it comes to rock candy, so that's all this is. This is just sugar dissolved in water, but heated up. So they stick a wooden skewer in there, and you can watch this video on your own, that has some sugar already on it. And over the course of 5 days or so, you can see that the sugar that is dissolved in the mixture actually starts to crystallize onto that wooden skewer. So that is the sugar coming back out of the water, right? It was dissolved into it, and it was a saturated solution. It's actually a super saturated solution. And given the opportunity, that sugar will just come right back out and form sugar crystals. Now, in this case, it's performing really big sugar crystals, not like the sugar crystals that you would have in your canisters at home. So this is a lot of sugar, right? But that's all it is. This is literally just sugar. And you can see it's very syrupy. But that's all it is. That's what rock candy is literally just sugar crystals. It's just big sugar crystals. So that means that had to have been a physical change. Physical change. They're actually talking here about how they used Kool-Aid to try to flavor it, and it didn't really work very well with creating crystals. Kind of inhibited that. When you do actual rock candy like this, you can use food coloring to get the color, and then you can use flavoring, candy flavoring. So I highly suggest it. It's kind of fun. You have to wait 5 days though in order to get it to work, but it's pretty fun. So again, watch the rest of this video if you want to. It talks about words that you don't necessarily need to know about solubility, and maybe it will give you nightmares about chemistry. But anyway, so anything that is dissolved is also always means physical change, because you can get that back out, especially like evaporation. Right, that's literally what the distillation process is. When you have distilled water, all they do is boil the water so that it evaporates. They collect the evaporated water someplace else, leaving everything else that doesn't boil behind, and so you end up with pure water out of that process. So that's what's going on. So what is this? I'm sure some of you have probably maybe even done this before: Diet Coke and Mentos. So what is this? So okay. Well, then I guess you're going to have to watch on your own, because I'm not going to stop this recording to figure out what's going on. It's just I'm probably not in the right account for my school. Okay, so you watch this. So what is it? Diet Coke and Mentos. Is it a physical or chemical change? It's a physical change. Okay, it's a physical change, and the reason for that is because when you drop the Mentos in, all you're doing is creating a place that allows the carbon dioxide to come out very quickly. Now, when you open up a 2 liter of Coke, you automatically already start to get fizzes and stuff like that. Now, the fizz is actually literally carbon dioxide that has been pushed so hard into the liquid that it is dissolved into the liquid. So a carbonated drink is carbon dioxide dissolved, carbon dioxide gas dissolved into the liquid. And what did I say? Dissolving is always a physical change. So in this case, the Mentos is allowing more carbon dioxide to come out of the solution quickly, which causes the really big fountain. So Diet Coke and Mentos is a physical change. The next one that I'm going to make you watch yourself is this one: how to unboil an egg. So if you hard boil an egg, right, can you unboil an egg? And I want you to watch this video and tell me whether or not boiling an egg, is it chemical or physical? Okay, is it chemical or physical? And that there's a discussion question that is set up for you to tell me. So what you're going to do is on page 16 in the e-text. Okay, remember 16, it's called physical versus chemical changes. You're going to run through the 8 there and state whether or not that's a physical or chemical change. There is a D2L, there's a Brightspace quiz that's set up. It is actually not graded, and you can take it as many times as you want to see whether or not you are in agreement with me on whether things are physical versus chemical changes. So go in there and take a look at it. Again, not graded, but should be done and could affect your attendance grade when I finally get around to figuring out attendance for the course. So you need to do this. Page 22, the burning a candle part 2, 22. I don't know. I'll make sure the page numbers are right on the assignment. So make sure that gets done after you watch the burning candle part of this video. And that is what we are doing this week, physical and chemical changes. So you guys have a great week and shoot me an email if you have any questions. All right. Bye.